Hello, asynchronous learners. So this video goes over the nuclear power plant and how it's able to produce energy. So if you remember, we have fuel rods, and your fuel rods, I'll draw it here on the side, have little pellets. These little pellets have enriched uranium. So enriched uranium, if you remember, is uranium-235. The one that is most abundant, so the one that we will find, is 238. But we want enriched uranium, so that's uranium-235. So those are your fuel rods in there, and then we have control rods. Control rods are very important because they are what gives us the ability to control this reaction, and they're made up of boron or cadmium. They use this type of particle because it is able to absorb neutrons. So because it absorbs neutrons, that gives it the ability to control the chain reaction. And again, if you remember, in nuclear reactors, we want a controlled reaction. If we don't have any control over it, it becomes like a nuclear bomb, right? So we have our fuel rods and our control rods. They are in what is called a fuel assembly. So that whole little oval there is your fuel assembly. And your primary coolant, I want to make sure that you do know this, your primary coolant is boric acid. Boric acid. So that is your primary coolant. Again, that primary coolant is able to absorb those neutrons, and it makes it a lot easier to be able to control the reaction. So this reaction, guys, has a lot of energy, and when you have a lot of energy, you have a lot of heat. So what happens is that primary coolant goes through its tube, so that boric acid is going through here, and all that energy goes into the steam generator. So the key word here is steam generator. So what is inside there is H2O. So we need water in order to produce steam. Steam can be used to help us control and make that energy. So that steam, guys, is kinetic energy because there's tons of particles moving. And it's kinetic energy because it moves our turbine, right? So all that steam is what makes our turbine work. And then after the turbine, we go to the generator, and that's mechanical energy. So kinetic energy, mechanical energy, and then ultimately after the generator, it produces electrical energy. So that's why here it says electricity. This top part is very, very similar to what you saw in the fossil fuels in our power plants. So again, we have our control rods and fuel rods. Very important. This helps us control the reaction. Then that boric acid goes through that pipe. It goes through that pipe, and it has a lot of energy, so it has a lot of heat. So what happens to the water is you start producing steam particles. Those steam particles, the kinetic energy goes and they turn the turbine. That turbine turns it into mechanical energy, which goes into the generator, and ultimately your generator produces that electrical energy that we use. This reaction is a little bit different, that we have this whole other part down here. So we have a pool or a sense of water there, and remember that turbine is being spun by steam, so that is going to be hot. So that warm water exits. You have a cooling tower, which makes water colder, right? It cools it off. So you cool off your water, and then it goes back into your pool. That pool then puts in cool water because, again, that condenser, when something condenses, it turns it back into water. So you have cool water in this condenser, and then that condenser returns it here to the steam generator. So that's how you're able to keep water within this system. If you notice, there's a containment structure. So with your steam generator and your reactor, you have a containment structure made out of steel. So again, we have safety measures in place. That is a very, very big thing when you're working in a nuclear power plant. You want to be as safe as you can. You want to have control of this reaction, because if control is lost with nuclear energy, the ultimate price is like an explosion, a nuclear explosion, which can have a lot of bad effects on it, right? So again, here, what you add is after the turbine, the steam that leaves the turbine makes warm water. The warm water exit, it goes to a cooling tower, it goes to your pool, and then the pool puts cool water in the condenser, so your steam becomes water again and goes back to your steam generator. This is just the system that they have in place because there's so much kinetic energy, there's so much heat being created, and that's how you're able to use nuclear energy as a source of energy. So I hope this helps a little bit more in understanding the process. This is what your project will be. I have the date for the project set due Sunday. If you need an extension, please reach out. All you have to do, class, is either use a visual like this. You can print it out. You can do it digital if you have the methods, or you can draw it out. So I want to show you really quickly on Flipgrid. Flipgrid, it is already uploaded. There's a code. All you have to do is record it. If you can make TikTok videos, guys, you can do this. I want to make sure that you do know your videos that you submit to myself will be private. The reason that I want you to submit a video explaining the process again, it can be exactly like mine, but I want you to practice, and you will take a course in college that is called seminar. I had science seminar because I was a science major. Other majors have their own seminar, but you practice presenting. So first half of the semester is a professor teaching you how to come up with a good quality presentation, and the second half of the semester is you actually presenting it and getting graded on it. So I want you to feel comfortable explaining it to me. Again, it'll be like if we're one-on-one. The videos, I don't unlock them for the rest of the class, so no one else can see them. I unlocked mine, so you can just see as an example, and let me play it for you really quickly.
Hello class, I wanted to record an example of what I'm looking for. So we start off with our fuel assembly, which has both control rods and fuel rods. This fuel assembly is found in your primary coolant, which is boric acid. This reaction is very, very hot. So what happens is that it interacts with a steam generator. A steam generator has water, and they don't mix, so the primary coolant is kept separate from the steam generator, but they do interact. Because this reaction has so much energy and it is so hot, what happens is that water creates steam. Steam is very important because it produces that thermal energy, and that turns into kinetic energy that helps spin that turbine. So once that turbine is already spinning through kinetic energy, it goes into mechanical energy to our generator, and after it goes into our generator, it is producing electrical energy for us. So between that, steam from the turbine enters the condenser, and the condenser has water in there that turns the steam back into water, and it goes back into our steam generator. That's how we're getting water back in there. A thing to help us is that we have a pool with cold water, so that pool is putting cold water in the condenser and warm water is coming out into the pool. One of the biggest things is this whole side of our reaction is kept in a containment structure for our safety. Hope this helps, guys.
So I added a little bit more time. I felt like I very rushed through my Flipgrid. I had it set at 90 seconds, but I am giving you 2.5 minutes. So you have 2.5 minutes. This was, I know, guys, I'll give you my autograph later for my beautiful art. This was the one that I drew. You can definitely do this. Or you can print one out or use one through a digital platform. What I do want to see is that you explain it to the best of your ability. I just want to make sure that you understand it. It will be a project grade. It will be a summative, but it'll be in after your progress report comes in next week. You can upload a video as well, so it gives you that option. Let me see if I can exit here. So how does a nuclear power plant work? The only one that will be active will be my own. But you can upload, you can just record it. The code is in there. It's under assignments. Again, please reach out to me if you need any extra time. But that's about it. The last video was about where you get your neutron. Your neutron, guys, is... I can show you the notes. I took notes on it for you, and they'll be uploaded. But the neutron, you just get it from a spontaneous decay. It doesn't come out of thin air. You use spontaneous decay. The one that we use in the US is Californian, and that is the biggest thing. It comes from an isotope, spontaneous decay. And that's it, class. Please reach out to me if you have any questions. Again, you can draw out your visual, your schematic. You can print it out. The biggest thing is how you explain it, and your example will be there, and they will be set private. Y'all have a great day, guys. Bye.